Welcome to the banker lamp. Please enjoy the video.
You begin by recognizing the core rule. The derivative of ln x is 1/x because ln is the inverse of the exponential. Once you have a composite, apply the chain rule. Compute u, then divide by u. Make sure to convert any log base into ln x/ln a first because that constant 1/ln a carries through. As you work, watch the domain. ln requires positive inputs, so restrict steps to x0 to avoid invalid moves. Once you have messy products or quotients, take natural logs of both sides to simplify. ln of a product becomes a sum, ln of a quotient becomes a difference. That turns multiplication into addition, which is easier to differentiate. Then differentiate both sides implicitly, remembering y appears inside d/dx ln y. Multiply back by y at the end. Make sure to simplify algebraically before substituting, because reducing fractions early prevents algebraic mistakes. To finish, handle exponentials like f(x)(gx) by taking ln of both sides and differentiating g(x) ln fx, then solve for y. Once done, simplify carefully, cancel common factors, and combine like terms to get a clean 1/x style fraction when possible. Make sure to check domain restrictions and plug in boundary values or limits if results look odd. Troubleshooting tip: if derivative explodes or is undefined, recheck the domain and any lost absolute values or sign errors during simplification.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.